Hello everyone. Title of this video is Solve Applications Using Systems of Linear Equations with 3 Variables. So in this video I'm going to go over several examples of applications, and anytime you hear the word applications, it's usually word problems, right? So I'm going to go over several word problems in which we'll have to set up a system of linear equations with 3 variables, 3 unknowns, and then solve that system and answer whatever question is being asked. Right, so I'm pulling these exercises from a free online textbook at openstax.org. This book is their Intermediate Algebra 2nd edition, and I'm in section 4.4 on Solve Systems of Equations with 3 Variables. The exercises I'll be doing are exercises 190 through 193 under the heading Solve Applications, right, using systems of linear equations with 3 variables. Right. Example 1 in the video will correspond to number 190. Example 4 will correspond to 193. And I will also have timestamps for when each of these examples starts in the video. I'll have the timestamps in the description of the video. So if you want to skip around or just see one particular example that, just look, say you want to see number 192, you just, click on the timestamp for example 3. Also, when you're going through the video, when I bring up a new example, pause the video and try working on it yourself first. Try to solve the problem yourself first, and then watch me do it. And then you can compare, how you did it to how I did it, and see how well you're doing, see how far along you've come with the material. Okay. All right, so let's get into it. So hopefully you see my paper coming up in the lower right corner now, right with my hand over it. So the first of these examples is going to be exercise 190. And it reads, the sum of the measures of the angles of a triangle is 180 degrees, right? It is 180. The sum of the measures of the second and third angles is twice the measure of the first angle. The third angle is 12 more than the second. Find the measures of the 3 angles. Alright, so just as with any other word problem, or any other application, I've read through the problem, and then I identify what's unknown, right? What are my variables? Things that can change, things I don't know, things that they're asking me for. Now they're asking me for the measures of these 3 angles. So there are 3 unknowns. Now I'm going to call them X, Y, and Z. So let's say X is the measure of the first angle, Y is the measure of the second angle. Hopefully you know the ditto marks, right? This just means I write the same word, measure of. And Z is the measure representing the measure of the third angle of some triangle. All right. So I read through the problem, I assign expressions or variables to certain unknowns, right? What they want, what I don't know, what they're asking me for, right? Then I read back through the problem again, turning key information into equations or inequalities. Here we're going to be turning these into equations, and it's going to be a system of 3 equations with these 3 variables I have here, X, Y, and Z. So I'll read these and just write write their translations in math. Right? This is probably the hardest part, right? Being able to translate sentences into mathematical statements. So reading back through exercise 190 again, the first sentence gives me an equation. Right? The sum of the measures of the angles of a triangle is 180. Well, the sum of the measures of the angles of a triangle, that would be x plus y plus z. Right, the sum of the three angles in this triangle is, usually a verb will be representing the equal sign, is 180. So there we go. First equation. But I should be finding two more, and there are really just three sentences here that get turned directly into equations. So the second sentence, the sum of the measures of the second and third angles is, so I got the is there where the equal sign goes. So on the left side of the equal sign is the sum of the measures of the second and third angles. Well, I called that y and z, right? So y plus z. The sum of the measures of the second and third angles is twice the measure of the first angle, which would be 2 times x. Okay, second equation, wonderful. And then there's one more sentence after that. The third angle is, right, so the third angle was called z, is, right, z equals 12 more than the second angle. So there's the second angle, y, and then 12 more than that would be plus 12. And here is a system, right, with three equations and these three variables, right, the measures of these angles. Okay, now I'm going to solve this. All right, so I'm going to pull this up on a bigger, make this a little bigger. Okay. Now that I've got the system set up, I'm going to now go ahead and solve it. Now you can solve this through what's called the substitution method, but in this particular, in a previous video I solved a system like this with what's called elimination. So I'm going to stick to elimination. So what I'm going to do is I'm going to first get all the equations in that form ax plus by plus cz equals d. Right? I'm going to get all the equations in the form where I have all the variable terms on one side, constants on the other. And I'm going to line up like terms. Okay, so the first equation, x plus y plus z equals 180. That's already the way I want it. The second equation, all I would need to do is subtract 2x. So I'd have negative 2x plus y plus z equals, and if I subtract 2x, I'd have 0 on the other side. And then for this third equation, to get all the variable terms to one side, I would just have to subtract the y. So I'd have negative y, and I still have positive 1z on the left equals, and then when I subtract the y, I have 12 on the right side. Okay. So again, you don't have to do this. Right? If you see a faster way to solve, be my guest. All right. Absolutely, go do that. Solve with substitution or some other method. I'm doing this because I like doing elimination personally. All right. Okay, so what I'm going to do is now that I've got all three in that form, I'm going to call the first equation here equation 1 or just E1. This second equation here, E2, right, equation 2, and the third equation, equation 3. All right, now you may notice that equation 3 has just two of the variables. Right? So I'm going to keep that equation. I'm going to keep equation 3 the way it is, negative y plus z equals 12. And then I'm going to eliminate x from the first two equations. And that'll give me a second equation with just y and z, and then I can solve that system for y and z and then go back and solve for x. So I'm going to eliminate x from E1 and E2. Right. So if I take equation 1 and equation 2, and I wish to eliminate x, the second equation has negative 2x, so I need to multiply the first equation, both sides, by 2 to get positive 2x, right? So that way the coefficients of x are opposites, and I can eliminate them by adding. So I'm going to multiply the top equation by positive 2. Now let's see what happens when I get that. So the top equation, equation 1, becomes 2 times x plus 2 times y plus 2 times z equals 360. Second equation I didn't change. We have negative 2x plus y plus z equals 0. Alright, now the coefficients of x are the same, or opposites, sorry. So now when I add the equations together, they'll be eliminated. I got no x, and then 3y plus 3z equals 360. And because, every single coefficient here is a multiple of 3, I'm just going to multiply by a third and get y plus z equals 120. All right. Okay, so I'll call this equation y plus z equals 120. I'm going to call that equation 4. So now the equations I'm working with, equation 3 I kept, and equation 4, you see how both of these have just y and z and no x. So I'm going to solve this system, right? The system with equation 3 and 4. I'm going to solve for y and z, and then we'll go back to an equation with x and solve for x. So I've got equation 3 and equation 4. And notice that it would be very easy to just eliminate the y's, because equation 3 has negative 1y, equation 4 has positive 1y. So all I would need to do is add the equations and y will be eliminated. So here's what I'm going to get when I add those. Negative y plus y is 0. Z plus z is 2z. And then 12 plus 120 is 132. And then to get z alone easily here, divide by 2. Right, so z equals, and then dividing by 2 gives me 66. Alright, so there's part of the solution. Alright, they asked for the measure of all three angles. Remember, z was the measure of the third angle. So the third angle in the triangle measures, 66 degrees. And now, say go back to equation 4, substitute 66 for z, we have y plus 66 equals 120. And subtract 66 from both sides, y equals 54 degrees, or the measure of the second angle, that was y, is 54 degrees. All right, and then going back to any of these equations with x in it. All right, so I could go here. I'm going to go back to this equation here. We have y plus z. Alright, so 54 plus 66, which, y plus z is just 120. We have 120 equals 2 times x. And then dividing both sides by 2, I see that the value of x must be 60. Alright, so I've got all three angles, and then I'm, just like you've seen in other videos I've made where you're solving applications, you should be writing the answers to word problems in sentences, complete sentences. So the measures of the three angles are, and I'm going to go x, y, z, because I called x the first angle, I called y the second angle, z the third angle. So 60 degrees, 54 degrees for the second angle, that was y, and 66 degrees for the third angle. Okay. There we go. Now let's verify this, right? Let's double check that this actually satisfies the three statements that were made in the problem. Right, so don't forget to check, right? Always check your solutions, sometimes even triple check. So here were the statements from the problem, right? The sum of the angles is 180. 60 plus 54 plus 66 is 180 degrees. That's good. The sum of the second and third angle, 54 and 66, is twice the first, right? 54 plus 66 is 120, which is 2 times 60. That's correct as well. And the third angle is just 12 more than the second. Well, 66 is 12 more than 54. So it works out. Right? The statements are satisfied. The system is satisfied by these three numbers. Okay? And you should always be doing that, right? Always checking your solutions. Make sure they make sense. All right. Back to the website. So that was exercise 190. All right, and example 2. Example 2 is going to be exercise 191. All right, and this one reads, it's about measures of angles of a triangle again. So the sum of the measures of the angles of a triangle is 180 degrees. All right, so there's again that first equation. The sum of the measures of the second and third angles is 3 times the measure of the first angle. And the third angle is 15 more than the second. Find the measures of the three angles. So just as with this is basically the same thing as example 1, just a few different numbers. So again, I'll let x be the measure, represent the measure of the first angle we're looking for. I'll let y represent the measure of the second angle, and z represent the measure of the third angle that we're looking for. Okay? Then reading back through the problem, using x, y, and z, the measure of the first, second, and third angles of some triangle, we'll write a system of equations. So the first sentence is the same as from exercise 190, example 1. The sum of the measures of the angles of a triangle, so x plus y plus z, is 180. So x plus y plus z equals 180. The next sentence, the sum of the measures of the second and third angles is, so second and third angles is again y plus z, is 3 times the measure of the first angle. So 3 times x. So I have y plus z equals 3x. And then final sentence there is the third angle is, so z is 15 more than the second. So the second was y, 15 more than that, right, is plus 15. Again, the only thing that's changed here is 2 became a 3 and 12 became 15, and then everything else is pretty much the same thing. Alright, so just as before, I'm going to rewrite this so that all the variable terms are on one side and stacked up. Again, there are faster ways of doing this. If you see a faster way, go ahead, right? As long as it's legitimately mathematically legitimate. But I'm going to do it with this elimination method. Right? So x plus y plus z equals 180. Subtracting 3x, we get negative 3x plus y plus z equals 0. Subtracting y in the third equation, I get negative y plus z equals 15. And I'll label this equation 1, this equation 2, and this equation 3, E1, E2, and E3. And I'll make this a little bigger again. Let's go to a bigger part, make this bigger in the video. And just as before, right, just as in example 1, I'm going to keep E3, right, I'm going to keep equation 3 the way it is, because it's got variables y and z but no x. So what I want to do now is make another equation with y and z without x. All right, and that's going to be by eliminating x from equations 1 and 2. So here's equation 1, equation 2. I want to eliminate the x terms. In order to do that, I would have to multiply the first equation by 3. All right, so that gives me 3x plus 3y plus 3z equals 540. And the second equation I didn't touch, right? So negative 3x plus y plus z equals 0. Now the coefficients of x are opposites, so when I add the equations to make a new equation, which I'll call equation 4, the x's will be eliminated. So I got 4y plus 4z equals 540, but every single one of these is divisible by 4. Divide both sides by 4 here, or multiply by a fourth, whatever you want to say, and we get the equation y plus z must be equal to 135. All right. This dividing by 4 is cutting in half twice, 270 then 135. So here is equation 4. Now, look at equation 3, look at equation 4, right? Both have just y and z in it. So if I look at equation 3 and equation 4, and it would be very easy to eliminate the y's again. Right? The y's have opposite coefficients in these, negative y, positive y. So I'm just going to add the equations now and write the result. Negative y plus y is 0, z plus z is 2z. And then 15 plus 135 is 150. Dividing both sides by 2, we get z equals 75 degrees, right? So the measure of the third angle that they're describing would be 75 degrees. And then going back into equation 4 here, I substitute 75 for z, we get y plus 75 equals 135, and then subtracting 75 from both sides, get y equals 60. Right, so the second angle they described, which I called y, would measure 60 degrees. Right, and then finally, I just go back to an equation that involves x. I believe an easy one would be this, again, this second one here. We have y plus z, and maybe even the first one. The first one would be easy too. How about back to the very first equation, right? I called that was equation 1. X plus, y plus z, 60 plus 75, or, y plus z that's 135 here. Y plus z is 135. Equals 180. Oops, sorry, that's in the bottom there. I apologize. I replace y with 60, z with 75, right? So we got x plus 135 equals 180. And then I subtract 135 from both sides. And 180 minus 135 is 45. So I have all three now. The measure of the first angle, x, second angle, third angle, y and z. 45 degrees, 60 degrees, and 75 degrees. But again, I'm going to write this in words. Right? The way that they said find the measures of the three angles, right? The measures of these angles are, and I'm going to put them in the same order that I mentioned, right? The x is the first angle 45 degrees. The second angle was represented by Y, so 60 degrees. And the third angle, 75, right, is 75 degrees. Now, check, all right, don't forget, check your answers. Make sure these three numbers here satisfy the statements. Well, the sum of all three is 180, that's true. The second and third, right, 60 plus 75 is 3 times the first. 60 plus 75 is 135. 3 times 45 is also 135, so that's true. And the third was 15 more than the second, and that is also true, right? 75 is 15 more than 60. So I have checked the solutions, put a little check mark. Great. Right, so back to the website. We're moving on now to exercise 192. This will be example 3. Alright, so this reads, now we're getting away from angles in a triangle. So it says, after watching a major musical production at the theater, the patrons can purchase souvenirs. If a family purchases 4 t-shirts, the video, and 1 stuffed animal, their total is $135. A couple, right, a separate couple, buys 2 t-shirts, the video, and 3 stuffed animals for their nieces, and they spent $115. And one final couple here, buys 2 t-shirts, the video, and 1 stuffed animal, and their total is $85. What is the cost of each item? All right, so this time I'm going to go a little different for Anya. Instead of using X, Y, and Z, I'm going to use other letters. It doesn't matter. Right? Just pick some letter that you like. So we're looking for the cost. Right? What we're asked to find here is the cost of each item. And these items are t-shirts, the video. How much does a t-shirt cost? How much does the video cost? And how much does the stuffed animal cost? So I'm going to let T represent the cost of a t-shirt. I'm going to let V represent the cost of the video of the performance. And I'm going to let S represent the cost of a stuffed animal. And again, you can use X, Y, and Z if you wish. Doesn't matter. Right. Just make sure you remember what represents what. Now the system, right? I've read through the problem. I've identified the unknowns, right? I've identified what I'm being asked to find. Now I read back through the problem and set up a system. Now, the first sentence that has anything to do with the cost of these things is the one about the family, right? If a family purchases 4 t-shirts, so they had bought 4 t-shirts, so they paid 4 times T, and then you add to that the cost of the video, right, plus V. You add to that the cost of a stuffed animal plus S, and they paid $135. I hope this makes sense here, right? They bought 4 t-shirts plus the video plus a stuffed animal, and that total cost is, right, equals $135. And that couple who bought stuff for their nieces, they bought 2 t-shirts, so 2T, plus the video, right, plus V, plus 3 stuffed animals, right, so plus 3S. And they paid a total of, right, equals $115. And finally, that last couple, they bought 2 t-shirts, 2T, the video, right, plus V, and 1 stuffed animal, right, plus S. And they paid a total of $85 equals 85. I hope the setup for this made sense. That's usually the hardest part, right, is setting up the system. And everything's set up the way I want if I'm going to be solving through elimination. Again, if you see a faster way than elimination here, go ahead and do it. As long as you're doing mathematically legitimate moves, it's okay. Alright, but I'm going to do that elimination method again. And it's already set up the way I want, right? All the variable terms on the left side of the equal sign, all the constants on the right. And I think it would be really easy here to eliminate the v's. Right, so I'm going to choose, right, so I'll call this again equation 1, equation 2, equation 3. And I'm going to choose to eliminate v. So for equation 1 and 2, right, equation 1 and 2, if I want to eliminate v, I just need to multiply the second equation by -1. Right, that'll give me, now equation 1's the same. I got 4t plus v plus s equals 135. And it's equation 2 I'm multiplying by -1, right? You have -2t minus v minus 3s equals -115. And then add these, right? And the coefficients of v are opposites, so they'll be eliminated. And I'll have 2t minus 2s equals 20. And since everything is a multiple of 2 here, I'm just going to cut everything in half. This is t minus s equals 10. Alright, so this is what I'm going to call equation 4, E4. I'll do the same thing over here. Now, instead of eliminating v from equation 1 and 2, how about 1 and 3? So equation 1, equation 3, and the same thing. In order to eliminate v, I'd only need to multiply the second equation by -1. So that'll give me 4t plus v plus s equals 135. And then -2t minus v minus s equals -85. Add these equations together, right? Eliminate the v's. So we have 2t, and not only are the v's gone, but the s's are gone as well. So I just have 2t equals 50. And there's I'll call that equation 5. Now equation 4 and 5 have no v's in it. But equation 5 is even nicer because it doesn't even have s's in it either. So if I solve this equation, we're seeing that t must be 25, right? Dividing both sides by 2. So that's the cost of a t-shirt, right? So a t-shirt must cost $25. And then I go over back to equation 4 here. 25 for t minus s must be 10. Well, that means s must be 15, right? Add s, subtract 10, or subtract 25, divide by -1. So the cost of a stuffed animal is $15. And I'll write all this in words in a second. And now that I have the cost of a t-shirt and the stuffed animal, now I just need to find the cost of a video. And again, you can go into any one of these equations. So I'm just going to go to the last one because it's got smaller numbers. If I go to equation 3, we have 2 times t, right? 2 times 25, plus v, plus s, but s is 15. That's equal to 85. Now 2 times 25 is 50. 50 plus 15 is 65. Subtract 65, you got v equals 20. Alright, and then I'll write in words the answer, right? I'll try to keep it on the same page here. Right. So remember, you should write the answers to all these application problems in words. So a t-shirt costs $25. That's what t represented. Period. A video costs $20, right? That's what the v represented. and a stuffed animal costs $15, right? That's what S represented. And there you go. And then again, check your answer, like in examples 1 and 2. Make sure it makes sense. Right? If I bought 4 t-shirts, that'd be $100. The video would be $120, and then put a stuffed animal on it, that's $135. That makes the first one true. If I bought 2 t-shirts, that's $50, plus a video, that's $70. And then 3 stuffed animals would be $45. 70 plus 45 is $115. 2 t-shirts is $50. The video makes $70. And add 15, that's $85. So these are the correct costs of those individual items. Wonderful. And then finally, back to the website, looking at exercise 193. And this will be example 4. Same setup, really, the same setup. You just read through, just like any other word problem, read through it, identify unknowns, assign some variable or some expression to those unknowns, read back through the problem, and set up equations or inequalities that'll help you solve the problem. Here it's a system of 3 equations. Alright, so this one reads, the church youth group is selling snacks to raise money to attend their convention. Amy sold 2 pounds of candy, 3 boxes of cookies, and 1 can of popcorn for a total sales of $65. Brian sold 4 pounds of candy, 6 boxes of cookies, and 3 cans of popcorn for a total sales of $140. Paulina sold 8 pounds of candy, 8 boxes of cookies, and 5 cans of popcorn for a total sales of $250. What is the cost of each item? Alright, so just as the last, this is pretty similar to example 3. Pretty similar to the thing with the stuffed animal, the video, the t-shirt. But here, we're talking about pounds of candy. So I'm going to let C for candy represent the cost of a pound of candy. Talking about pounds of candy, boxes of cookies. Right, I already used C for candy, so I'm not going to use C again. I'll use B for boxes. B represents the cost of a single box, a box of cookies. And the other thing mentioned here, a can of popcorn. I've already used C, so I'm not going to use C for can. I'll use P for popcorn. And P, I'll let P represent the cost of a single can, right? Of a can of popcorn, or tin of popcorn, whatever you want. Alright, so I read through it, assigned variables to what they want, what's unknown, and now I set up a system. Again, this is very similar to the last one with the costs and everything, and how much they're selling these things for. So if you look at the first sentence after, the second sentence, Amy sold 2 pounds of candy, so 2 times C, plus, she also sold 3 boxes of cookies, 3 times B, right, plus, and 1 can of popcorn, 1P. And the total sales she got from selling all these was, or is, equals $65. So equals 65. Alright. The next sentence, Brian sold 4 pounds of candy, right? So 4 times C. 6 boxes of cookies, right? Plus 6 times B. And 3 cans of popcorn, so plus 3 times P, for a grand total of $140 sold, so equals 140. And finally, the last equation, Paulina sold 8 pounds of candy, right, so 8 times C. 8 boxes of cookies, right, plus 8 times B. and 5 cans of popcorn plus 5 times P for a grand total in sales of $250. So this equals $250. So again, hopefully the setup made sense, the setup of this system after reading those sentences. All right, now I'm solving for, C, B, and P to get the cost of each individual item. Now again, if you see a faster way of doing it, fine. I'm going to do it through that elimination method. All right, now something I notice is that 2, 4, 8, those are nice multiples. So what I'm going to do is I'm going to call this again equation 1, equation 2, and equation 3. And I have decided I want to eliminate C's. So first with equation 1 and equation 2, I would just have to multiply equation 1 by negative 2 to get negative 4c, and then you have positive 4c. So I multiply equation 1 by negative 2. And that would give me negative 4c minus 6b minus 2p equals negative 130. And equation 2 I didn't change. So we have 4c plus 6b plus 3p equals 140. And look, this turns out real nice when I add these together. Because see, the c's are eliminated, the b's are also eliminated, and I have just 1p equals 10. So there's the p value, the cost of a can of popcorn. So 1 can of popcorn costs $10. Okay, let's do that again. I'll keep that in mind too, that p is 10. I'm going to keep eliminating c's. This time I'll do it from equation 2 and 3. And if I wish to do that, I would just need to multiply equation 2 by negative 2. That way I'd get negative 8c and positive 8c. So I multiply equation 2 by negative 2. And that would give me negative 8c minus 12b minus 6p equals negative 280. And equation 3 I didn't change, right? 8c plus 8b plus 5p equals 250. Add these equations together. C's are gone. You have negative 4b minus p equals negative 30. Now don't forget, the value of p is 10. So if I plug this into that equation, we'd have negative 4b minus 10 equals negative 30. And then I would add 10 to get negative 20, divide by negative 4 to get b equals 5. So b, remember b represents the cost of a box of cookies. So 1 box of cookies costs $5. And then finally, now that I have a value of b and a value of p, I just need a value of c, and I'll go to the first equation. Let's go into equation 1. We have 2 times c plus 3 times b, right, 3 times 5, plus p, right, plus 10, will be equal to 65. And 10 plus 15, that's 25. I'd subtract 25 to get 40, then divide by 2 to get 20. All right. So, when I'm writing the answer, remember you should write the answers in nice full sentences. A pound of candy costs $20, right? That's what C represented, right? Was the cost of a pound of candy. So a pound of candy cost $20. The B was the cost of a box of cookies, right? A box of cookies cost $5. And finally, P represented the cost of a can of popcorn. A can of popcorn costs $10. There you go. and then double check, right? Make sure that the statements hold true, right? What Amy and Brian and Paulina sold. If I sold 2 pounds of candy, that would be $40. 3 boxes of cookies would be 15, making a total of 55 so far. And then add on $10 for the popcorn, that is $65. 4 pounds of candy is 80. 6 boxes of cookies is 30. 80 and 30 is 110, and 3 popcorn cans is 30 more, would make 140. That's good. 8 pounds of candy would be $160. 8 boxes of cookies would be another $40, making $200 there. And then 5 popcorn cans would be another 50, 250 total. It works for all 3. All right. Wonderful. All right, so again, the same setup every time. Read through the problem, identify what's unknown, what they want you to find out. Set up those variables. Then using those variables and going back through reading key information, right? Translating sentences and statements into mathematical equations or inequalities. And here it was a system of equations, right? And then solve that system and answer the question. Hopefully watching me go over these 4 examples help you out when you're working on something similar. And thank you very much for watching.